So as he mentioned, my name is John Matherly, and I am the founder of SHODAN. I don't know how many people here have heard of SHODAN, but just as a background, what we do is we scan the entire internet and we create a database of everything that we find on it. And we create various things out of that data. This is a map that I generated which shows, it's a heat map of the devices that we find on the internet. And just as a side note, as an engineer, I spend a lot of time on research and trying to figure things out, and I equate doing, more work with something that's in some ways more valuable. This was a research project I did over a weekend, and it's by far the most successful thing I've ever created. It's kind of silly, it's a map, it's one image, but it's been spread around the world. It's beyond belief. Anyway. And the goal of this talk for me today is to provide with you some numbers and trends of what we're seeing on the internet happening today. And to get started, I want to make sure we're all on the same page. And when I say the internet, I don't mean the World Wide Web. Now, this is a fairly technical audience, so I think you're probably already aware of this, but the way we see the internet is very much like this iceberg. 99% of the population only operates above. They operate on Facebook, Reddit, all the websites that you see, but the internet is so much more, right? We see factories, we see webcams, we see so many more things out there that are not part of the World Wide Web. So I'm talking about the internet, not the World Wide Web. And to kick it off, I want to give you an idea of the services that are running both in the United States and the world as a whole. So the most common service is web servers, not surprising. Then 443 HTTPS. Then the third one, I think that might surprise some people, is CWMP. That's a protocol that ISPs use to manage their modems. So right off the bat, the third most popular service is a way that ISPs manage devices. There are millions of these things out there. They're very homogeneous. They tend to run the same firmware. And if there's ever a problem in those, it's going to be a giant pain. We've already had some problems with CWMP. It's a kind of complicated protocol with many optional components. There have already been vulnerabilities in it, so we know it's a problem, but I want to take note as well, on the left side in the US, you see the fourth one is also CWMP. However, ISPs decided that we're going to change the port. We're not going to put it on a default of 7547, we're going to put it on 4567, very random. This is something we see across the board. This isn't true of ISPs like large organizations, small businesses. They think they can hide a service simply by changing the port that it runs on. This is not a very effective strategy. Don't do it. Stay on it. The final thing I want to mention, so first of all, cPanel is really high up. But globally, Telnet is the 11th most common service we see. Now, it used to be higher, actually, so it's dropping down, which is good. But to give you an idea, Telnet, which is an antiquated, terrible service, nobody should ever use this nowadays, still immensely popular. I think this is largely also why attacks like Mirai were very easy and successful to execute. In terms of IPv6, right now what we're seeing is very biased. The way the crawling works, we're mostly seeing web servers, a lot of CDNs, things like that. I have to say, though, that if you were at my talk last year, I can tell you that we already found control systems running on IPv6. There is this notion among some security people that IPv6 will solve a lot of the problems in terms of host discovery, like, it's so big the range. I don't need to worry necessarily about protecting everything because nobody will find my device. That's not the case. Please, let's not do the same mistakes over and over again. IPv6 is not going to solve that problem. I've put this in here to give you an idea that, yes, IPv4 has been largely fully allocated to all organizations, but within those allocations, we're still seeing large usage growth. This is a breakdown of the countries that we are seeing basically increase their connectivity to the internet. So there's still significant growth around the world, just not in largely developing countries. I think it's interesting we can measure that. And let me talk briefly about SSL and in the US. It's actually pretty good, honestly. Most countries I go to, and I provide a similar breakdown, they have a disproportionate amount of Heartbleed and SSLv2 running in their countries. And the US accounts for 52% of all HTTPS on the internet, which kind of makes sense with Amazon, all the cloud providers, all large hosting companies. In terms of SSLv2, however, you only account for 23%. So you're doing better than you should. And same for Heartbleed. Only 20% of all Heartbleed on the internet, the devices running exposed to Heartbleed, are in the US. So this is good news. However, when you look at the devices that are still vulnerable in the US to Heartbleed, it turns out a significant number of them are this. This is a security system, like security cameras. If you can't read it, the logo or the company motto is simple, reliable, secure. They're vulnerable to Heartbleed. You know. This is not the worst, though, because in most countries I go to, actually, the most common device that is vulnerable to Heartbleed is a Fortinet firewall. We see a lot of these firewalls deployed, and how often do you patch your firewalls? I mean, you guys probably do, but many other people don't. And it turns out they're very often vulnerable to Heartbleed. In the US, you only have a few thousand. It turns out the security camera people are way above that. So, but you still have them in the US, too. And I think it's a good lesson that just because you deploy a security product doesn't mean you don't need to support it or maintain it. And let me briefly talk about control systems. So this was a focus of my talk last year, where I provided a lot more information. For this year, I just want to provide a brief update to what we're seeing in terms of numbers, so you have a general sense of how many control systems there are actually on the internet. And when I say control systems, I mean I only count devices that expose an actual control system protocol. I don't include web servers, I don't include VNC, I don't include a bunch of other things. I only include devices that are running Modbus or any of these industrial protocols. This is a graph. You don't need to be able to distinguish all the colors. The general idea is we are seeing a linear growth in ICS on the internet. So about year over year, we're seeing 10,000 more devices coming online on the internet. In terms of raw numbers right now, we're seeing 100,000 on the internet directly connected, and pretty much half of them are in the US. So this is one area where the US is leading and it's bad. It's by far the worst in the US. One reason for that is these control systems, turns out a lot of them are on mobile networks, because in Europe, many other countries, mobile networks use carrier net, or they have whatever else. In the US, if you have Verizon Wireless and you're a business, you're going to get an internet-facing IP address. And that's why we see a lot of these control systems, they just get, an engineer shows up with a modem, plugs it in, done. We got internet connectivity now. Well, you're also publicly facing. And as I mentioned with CWMP, we're also seeing a growth in the ICS world where people are moving from standard ports to non-standard ports in an attempt to evade any detection. This is in 2016 on Modbus. There were 664 devices running Modbus on port 503. The default port for Modbus is 502. And now in 2017, we're seeing 960 results. These are not huge numbers, right? But we're seeing this as a trend across the ICS space, where people are feeling like instead of deploying a firewall, instead of putting it behind VPN or anything else like that, they're just changing the port number and no other tool will be able to detect it. So there's a lot of education that still needs to be done because people don't fully realize, a lot of these OT guys, what it means to be hooked up to the internet. We have heard from people that say, we are secure because we have a static IP address. It's only ours. I'm like, that's not how it works. But they don't know. They don't understand, right? This is an education problem. They just don't have that background. And in terms of services, I don't know whether you can read this, but the takeaway from this is the majority of ICS that we continue to see on the internet are buildings. This is university campuses, libraries, not many hospitals, good, factories, things like that, a lot of buildings. That's largely what we see. Part of the reason that the numbers have also increased And that's why I project overall a 10,000 year-over-year growth in ICS. But Shodan's also added a few more services. That's why you've seen a bump. And one of the services we added was for Lantronics. These are Ethernet to serial adapters that you can hook in. So if you have a serial control system, you just use this adapter and all of a sudden you can talk over the network. Really useful, not expensive to buy. And these devices have a really cool feature. If you forget your password, you don't need to worry about it. All you need to do is ask the device what the password is. I'm serious. You send it a packet, like an empty packet, to the service, and it just returns the password. This is the default. You can disable it. Like you see here, you are able to secure it if you go in and change the setting. But by default, and this is for the setup process, so when you first get the device, their software uses this service to give you the default password, right? But it's a service that keeps running. And this issue, by the way, has been known for, I want to say, 5 years at least. Still not patched. So these things take a long time to fix. I mentioned earlier that the US basically 50%. Canada appropriately is second, neighbor. Good. Sticking together. And then the rest are largely Europe. Developing countries have more money to spend on ICS and making it internet connected so they can save money, provide their business with more intelligence. And invariably, they put more on the internet. Taiwan is a bit of an outlier. It's largely because there is an ICS vendor called Moxa out of Taiwan, and it turns out they have a lot of business there, and they put everything on the internet. I don't know why. I was recently in Singapore, and they don't understand either why so much is on there. So Taiwan's the outlier, in my mind. I should mention also that Russia is pretty low on that list. Given the size and number of devices that they otherwise have on the internet, fairly low. However, China is really low. I mean, we see a lot of webcams, we see a lot of other types of devices on the internet in China. We don't see ICS in China. That is just not something we see very often. And the ICS we do see is not, this doesn't look like it's really super important. So, I mean, just to give you an idea, they're behind Hungary in terms of internet exposure for their control systems. I think they're doing a very good job in that regard. And now I want to move on to IoT, which is largely what Shodan is known for nowadays. And last year I mentioned the smart egg carton. If you're not familiar with it, there's like it's an egg carton you can buy, still available now, where it'll tell you over your phone how many eggs you have remaining in the carton in your refrigerator. Check it out, it's really cool. And we continue this trend of going bananas in IoT. This is a smart fork. So this is a fork where it'll detect how fast you're eating. And if you're eating too fast, it'll start vibrating. So you have a harder time eating, supposedly. So everything is connected, so if you need to get some statistics about your eating habits on the phone, no problem. I couldn't make this up. This is another one I find funny. It's a juicer modeled after Keurig. So this is like a $700 machine that you buy, and you buy packs from them, and they squeeze out the packs to give you the juice, right? It's $700. It's insanely expensive, but it's even funnier because you can just buy the packs and squeeze them out by hand. And it was like, yeah, the company's having problems convincing people that they need to spend $700 on compressing a bag, but And it's all connected, it's all super amazing, And before you ask, well, is this on the internet? Yes, it is. A lot of these things are on the internet. You can find them. This is an example of, they have smart kettles. So, you're at work. You really want to have tea when you get back home. What do? I mean, right now, you're screwed. There's nothing you can do. You're at a conference. No tea for you. But if you had an iKettle, your life would be different. You could pull up on your phone and heat it up right now. So by the time you get home, it's going to be boiling hot water. It's fantastic. So, and you can see the temperature, you can control it, and no authentication, obviously. And this is a video also I used last year again, but this is my home TV, and I'm scanning it with Nmap. Just to give you an idea, if you haven't seen this, I'm scanning it with Nmap, just default settings like -A, and it launches an update process and pulls up the menu. This makes me very nervous. it turns out that this is a Vizio TV. When you develop software for a cell phone or any smart device, you run in debug mode. So you can control the software as you develop it on your remote device. Great for development. It turns out they kept the debug mode enabled when manufacturing them. So all these TVs are full developer access enabled. No authentication required, obviously, otherwise I couldn't have done this. And in terms of numbers, IoT is difficult to track for us right now in terms of global numbers, and I don't want to give you misleading numbers because it's changing a lot. Also, the definition of exactly what is IoT and what isn't. I know some people in the ICS community are not too happy about being called IoT, so I won't give you absolute numbers of IoT. But I can tell you that in terms of growth, this is a product that came out, I think it's 2015, and the first year afterwards we saw a significant bump, and now we're seeing for a lot of products like year-over-year doubling of the devices that we see on the internet. So just general ballpark, doubling of IoT year over year. So for me, more meaningful in many ways is not looking at the number of devices, but the density of devices per country. And this is a breakdown that was performed by the OECD in collaboration with SHODAN. And can you spot all the typos? I wish I could change this slide because there's like so many typos. But there are many typos. This is a statistic that shows you how many IoT devices per capita. Somewhat unsurprisingly, this is South Korea, not North Korea, obviously. South Korea is leading. I think we all have this instinct that, South Korea they like their gadgets, everything is connected. And coincidentally, they're also the most exposed across the board for most of the IoT products. But that's a different story. And this is just, I think, interesting as a general point of view to understand which countries are deploying IoT and how many products are they buying. If you're not a developer, you probably didn't hear about this, but this is big news in the developer community because a lot of these IoT products are made by startups. They use modern technologies for developing them. They use Node.js, they use Go, they use, commodity developer tools, easy to use. However, it turns out last year there was an incident where in Node.js, one of the most popular platforms for developing nowadays with JavaScript, the way you develop software is you have dependencies. You pull in the dependencies to make your project work. One of the dependencies that a lot of projects relied on was pulled from the repository. So all of a sudden, if you want to compile or deploy any software using this dependency, everything broke. And so what was this dependency that broke thousands, actually more? It was a function, the whole library was a single function whose responsibility was to pad a string on the left side with spaces. So you have a string, and you want to add some white spaces on the left side of it. There's a library for that. And somebody pulled that library, and it broke everything. I mean, it was a complete disaster for like a few weeks until they figured out how to bring the thing back. This is insane, right? I mean, I don't know whether everybody here understands what I'm saying, but it's really ridiculous. It's like having a library to tell you how long a string is. There is that too, but it's just, this is the ecosystem that they're operating in. Like, for example, these smart TVs, they actually run, like the Samsung ones I know, they run on Node.js. So all these developer technologies that we're seeing have sort of flimsy-ish backings are being used to develop these IoT products. And unsurprisingly, this year, as our first major trend that I think everybody's realized is embedded is what's being attacked everywhere nowadays. So embedded is sort of like shooting fish in a barrel right now. You saw earlier I mentioned Heartbleed on these security systems. It turns out a lot of these embedded systems, those companies don't have a history of understanding how to handle patches, how to deploy things, how to talk to their customers about security problems. And I mentioned last year this, kind of cool thing that you can do with IoT. This is a breakdown of which universities needed their toner replaced. So because you can talk to the printer says, hey, I am low on toner, and you can aggregate that information to tell you how many, which universities need to have their toner replaced or paper stocked up, right? You can measure this. Yeah. However, we've seen a drop in printers on the internet after this incident. I don't know how many people remember this, but somebody decided to send Nazi propaganda to all these public printers. I think this was actually like a concern for many security people for a long time, is what if somebody sends, this kind of offensive material to these publicly available printers? Who's liable? As an organization, I'd be terrified if this happened to me. And I think many organizations were, and that's why nowadays we're seeing way fewer printers. I can still give you a breakdown of, toner stuff, but way fewer than we used to see because of the attacks. And then Mirai happened in the last year, and that just blew everything out of water. Right? I mean, this is a chart showing the bandwidth that the various DDoS attacks have had over the years, the max bandwidth. And I added some labels for when NTP reflection attacks became big, and then finally, Mirai at the right side. Like orders of magnitude more bandwidth was sent with Mirai than anything else before it. Right? It took down Dyn, it took down many different websites. Huge impact. However, for me, it seemed like a very familiar story. I cannot believe how many people are not aware of this project, but the Internet Census 2012. If you have not heard of this, you need to check this out. In 2012, somebody compromised 500,000 embedded systems using default credentials, installed Nmap on all of them, and scanned the internet. So when I heard Mirai, I was like, this is like 2012 all over again, only Mirai was, in my opinion, less sophisticated. The person doing it in 2012 was obviously with an academic background, because he wrote a paper, all the data is publicly available. I mean, he Nmapped the internet using all these embedded systems, which is just amazing. And all the data was publicly available. He also created a really cool GIF of like how devices are coming online, offline over 24 hours. Really cool stuff. But so from my perspective, when I heard Mirai, I'm like, this is kind of old news. Right? I did not think this was advanced at all. I mean, what Mirai did was just log in, default credentials, install some software, and attack it. It's not very complicated in my mind. And it's not just attacks that we've seen. We've also seen an increase in sort of gray/white hat compromise of these embedded systems. This is a case where Ubiquiti is a maker of software-defined networking equipment. It's really cool stuff. They have a vulnerability, however. They have a few vulnerabilities. And so what somebody did, nobody knows who is writing this, somebody wrote a worm that goes on the internet and compromises all of these Ubiquiti devices. But they don't do anything malicious. Not really. First of all, they install their own account and they change the default credentials. And they change the host name to let the owner know how the device was hacked. So they go in and they go across the internet, and it's still happening. If you go to SHODAN, like new devices keep being hacked by this worm all the time. And they're just basically, and after they hack it, they also fix the hole. So they hack the device, they fix the hole, and they let the owner know what the hole was via the host name. I think we're seeing a trend where people are starting to get fed up with these embedded systems being terribly insecure, and you can't do much. Well, some people are going this route. Another obvious trend, ransomware. I'm going to talk about WannaCry a bit later, but first I want to talk about what we saw with NoSQL ransomware. So this year is the first year where we've seen actually people basically delete databases and hold them for ransom. We've talked about internet accessible databases for years, and nothing was ever done with them because you couldn't really pivot from a database into an actual botnet unless there was a vulnerability in a database. Well, now you don't need to do that anymore. People have decided that you can just connect to the database, dump all the data, delete the database, and then ask them for money. This is a very common business model nowadays. It's very successful. However, there's the one caveat. It is different than almost all other ransomware in that they don't actually download your data. So they will connect to your database, they delete everything, and leave one message saying, pay us ransom to get your data back. However, they never download your data, so there's no way of getting it back. So I call it ransomware because it looks like ransomware, but it's not really. And I'm very curious how this is going to pan out over time, because I think one reason why ransomware works is that you know you're going to get your data back. It's a business. If you don't deliver after somebody pays, that's not a sustainable business. So I'm very curious where this is going to keep going. So far it has. We saw the first ransomware early this year in January, and right now we're still seeing this happen every single day.